Okay, let's talk about velocity, displacement, and distance. So I have some velocity graph here. Let's think about what this means before we start doing a bunch of math. So I'm going at some constant velocity of 10 meters per second for 3 seconds. Then I stop and I turn around and I start walking the other direction. I start walking back home at -5 meters per second for an additional 5 seconds. So we could graph out our position here. We'll call that S for position and time, assuming we start at 0. We start at home. I'm walking away at 10 meters per second. That will mean I have a line with the slope of 10 for 3 seconds. My slope here is 10 meters per second. So we know after, I'm going at constant speed for 3 seconds at 10 meters per second, I'll have moved 30 meters. This is in meters, this is in seconds. Now I start walking backwards, back towards the house at -5, or since I'm walking backwards, at 5 meters per second. So that will mean I'll have a slope of -5 up until 8 seconds. So here my slope is -5. So I started at 30. This is a 5-second interval here from there to there, right? That's 5 seconds going 5 meters per second in speed. I've gone backwards 25 meters then. I've lost 25 meters. I will end up at 5. So my final position, here, let's just draw this. Don't think of a coordinate system. Here's my house. I walked away at 30 meters per second, or at 10 meters per second. So I ended up, after 3 seconds, I was 30 meters away from home. Then I walked back toward the house. My final position is here, 5 meters away from the house. So my displacement is change in position. It's final position minus initial position. So S final minus S initial. That would just be 5 meters away from home. That is, displacement is always just the integral, in this case from 0 to 8, of v of t dt. Displacement is the definite integral of velocity. And we could figure that out using areas. This area right here, that positive area, is 30. 3 times 10. This negative area here, because we're below the axis, that's a length of 5. 5, that's -25. So displacement is the net change in area. That would be 30 minus 25. Meters per second will be my units. Let's write the answer. Displacement's in meters. 5 meters. That's meters per second times seconds. We just get meters. Distance doesn't care which way you're going. Think about this. You walked 30 meters away from your house. If you got your Fitbit on and you're measuring how many steps did you get in, your Fitbit doesn't care which way you're going. You walked 30 meters, and then an additional 25, you've walked 55 meters. Distance doesn't care about direction. Distance is the total area. This guy is the net area that takes into account pluses and minuses. Distance is the, what your book calls total area. And that is the integral from 0 to 8 of the absolute value of velocity. Absolute value of velocity, by the way, we also call speed. Distance is always the antiderivative or definite integral from A to B of speed dt. Speed is a positive or non-negative number. Velocity can be positive or negative, speed can't. So what we would do here, like could just figure it out, right? You walk 30 plus 25, it's 55. But if we wanted to see this in picture form, here's absolute value of velocity. If I were to graph that, this was at 10. And then this part, we make positive. See, instead of having him down here below the axis, we flip it up and make it positive. So now we want this total area, which was 30 plus 25, 55 meters. So total area, we make all the little regions positive. The classic example of that in the real world is distance. Distance is the definite integral of the absolute value of velocity. We don't care about direction. Displacement cares about direction. Anything moving away from the starting point, we would call positive velocity. In this case, toward we would call negative. Okay, that's a good place to stop on that one.